Atomic structure. Introduction. Our universe is an enormous space which is all made up of matter. Even the living and non-living things on Earth are made up of matter. For instance, a complete organism, such as human being, is made up of matter. An organism is made up of organ systems. Organ systems are made up of organs. Organs are made up of tissues. And finally, tissues are made up of cells. Likewise, entire matter, when repeatedly divided, there arises one situation where an ultimately smaller particle is formed which cannot be further divided. According to Dalton's atomic theory in 1808, the particle which cannot be further divided is called an atom. By the end of the 19th century, there was a big challenge for the scientists to determine the structure of this atom. Breaking the assumption of Dalton, scientists proposed that there existed smaller components in an atom. This has paved the way for many experiments which led to the discovery of subatomic particles. One such experiment was to explain electric nature of matter. We have learnt that when early man rubbed two stones together, there occurred fire due to frictional force acting between two stones. Similarly, when substances like glass or ebonite rod are rubbed with silk cloth or fur respectively, electricity is generated. On rubbing with each other, materials get charged. Where do these charges arise from? It can be stated that atom consists of charged particles. The flow of charges is electricity. Later, this has led to the discovery of Faraday's law of electrolysis, which proved the electrical nature of matter. Hence, Faraday suggested that matter and electricity are interrelated with each other. The electric nature of matter put forth by Faraday was supported by Thomson's experiment on electrical conduction. Discharge tube experiments. By the end of the 19th century, scientists named J.J. Thomson conducted experiments in cathode ray discharge tubes. A discharge tube is an evacuated glass tube which is completely sealed. When he applied a high voltage across two electrodes placed at one end of the tube, they gave rise to a beam of particles at cathode. Hence, these are called as cathode rays. The particles, when struck the walls of the discharge tube coated with phosphorus, produced fluorescent green light. To test the properties of particles, Thomson placed two electric plates around the cathode ray. He observed that the beam deflected towards positively charged plate, proving that the cathode ray is made up of negatively charged particles. Similarly, when a magnet is placed on a side of the ray, the magnetic field also deflected the cathode ray. When Thomson repeated his experiments using different metals as electrodes and observed that the properties of cathode rays remained the same. From the experiments which used cathode ray discharge tubes, Thomson was able to explain the properties of cathode rays. Cathode rays travel in a straight line away from the cathode. Cathode ray gets deflected towards positive electrode in an electric field, indicating the presence of negatively charged particles. Cathode rays are also deflected by the magnetic field, proving the presence of negatively charged particles called electrons. Cathode rays rotate pinwheel kept in their path, proving that the particles in them have kinetic energy. This kinetic energy causes mechanical rotation of the wheel. Cathode rays can also heat the metal foil, which produces light comparable to the light caused by the glow of fire. When a metal plate is placed in the way of cathode rays, it produces X-rays on striking it. Properties of anode rays. As an extension for the experiments conducted by Thomson, E. Goldstein performed an experiment with anode rays in the same discharge tube, which is filled with inert gas. A perforated cathode was used. A layer of zinc sulfide was placed at the back of the cathode. Decreased air pressure is maintained in the tube. He analyzed the properties of anode rays. Anode rays travel away from the anode towards the cathode in a straight line. Under the influence of electric field, anode rays were deflected towards negative plate, confirming the presence of positively charged particles. These positively charged particles, called protons, under the influence of magnetic field, deflected towards the south pole. On striking the zinc sulfide screen, they produced red fluorescent light. They have a mass many times greater than that of an electron. When the gas filled in the tube is changed, the charge to mass ratio, or E by m, of the positively charged particles is changed.